Okay. 77. This is the same thing we've been working on. This is called a system of inequalities. It's a system because there's two of them, so more than one, and they both have inequality symbols. Did I mention that one of your parents, not yours necessarily, but all of my students, got me an alligator squishmallow that I could cuddle while teaching inequalities? Okay, but he's not come yet because I felt all the packages and there's nothing squishy. Anyway, okay, so I hesitated even putting the squishmallow on the list, but then I was like, if people really know me, they'll know. Okay, all right, everybody. So what kind of shape is this thing here? What kind of a shape does that make on the graph? It's a curve. It's a curve. This is an exponential. Do you remember the problem we did on the resource page? So it's going to be a curve kind of like this guy here, this curve. Okay. In order to do that with a curve, we're going to make a table. So first, we're going to pretend that it's equals. I didn't really want to do that, although that's correct, but okay, so what I'm trying to say is this, since this is a curve, you can't really do y-intercept and slope. However, do you notice that it's like it's supposed to be y equals ab to the x and there's no a there? There's nothing there. Okay, when there's nothing there, it's a 1 because 1 times anything is itself. So the start is 1, and then we're going to times 2 each time. So 2, 4, 8, 16. We're not going to be able to fit all of these, but we can fit a few of them. And before we do anything else, the curve, do you see that it's going to be dashed? Okay, we need to say that real quick before we start graphing. So 0, 1, 1, 2, 2, 4, 3, 8. Okay, and then you get kind of a general idea of how this curve goes. But remember about the asymptote. And remember about the dashing. It does not have the or equal to on it, so that means it's dashed. Also on your digital escape, you guys should have noticed that if the points were on the line, it was not a solution if it was dashed, but it was a solution if it was solid. Okay, we're gonna test. I'm gonna test over here for space saving measures. Is 0, 0 an okay point to test for this curve? Yes, indeedy. And I swear, if they're both true today, I don't really know what I'm gonna do. I'm gonna be very upset in a very quiet fashion, but send CPM a very strongly worded letter about lack of falses. But anyway, okay. So 0 is less than 2 to the 0. And what is 2 to the 0? Super important question. 1. Gorgeous. 0 is less. Ah. No, don't let me forget to show you the joke. I picked it out myself. It might be a joke that just old people find funny. We'll see. We'll see. Okay. The blue is done. So that's it for the blue. Totally done. Okay, step one, pretend you have equals. We haven't done one of these in a hot minute. This is one where we have to get y by itself. This is on your final exam. Mr. Madaber and I just worked on the final exam together this morning, so it's a good thing to remind ourselves how to do. Minus x from both sides. Remember, don't combine. So the key is right there. Put the x in front and don't combine. Okay, now we're gonna pause. When there's nothing up there besides a negative, it's really helpful to throw a 1 in there. Then you can make that negative 1/4 x plus 1. Do you see what I did there? So I took that negative x over 4. I put a 1 in front of the x that we don't normally write, but then I used that to help make my slope fraction. Okay. Solid or dashed here? Solid. Okay, so I'm going to go up 1. Oh, it's already there. And then I'm going to go down 1, 1, 2, 3, down 1 over 4. I'm going to go up 1, back 4. Just make sure that I can line up my ruler. Oh crap, I did it wrong. I graphed it right the first place. Down 1 over 4, up 1 back. There we go. All right, come on, CPM. I believe in you. Everything's riding on this moment, because if it's not false, I'm going to be very upset. Okay, I'm going to plug it into the original back here. So 0 plus 4 to, oh, the CPM writers should be ashamed of themselves. Like, how are we supposed to learn what to do when it's false ever? I mean, you guys know what to do, but so irritated. You know what I need to do? Yeah, it's a unit test, but a little bit longer than usual. So our unit tests are 50 points. The final is a unit test plus a little bit more stuff, so it's 75 points. But it's pretty much a unit test. You do not have a separate unit test in chapter 10, and you also do not have a quiz in chapter 10, which is good and bad news. Good news if you don't want a quiz, bad news if you want more chances to improve your grade. But it's just not long enough. Did you notice my note to myself? That's for next year. It's my note to future me. Okay, but beside that point, this is done. Okay, do you guys know where the solution region is? Do you know what the solution region is? It's all of this that's double shaded. So it's like through here and then up this little bit and then there. Right? Hello? Double shaded? Okay. All right. You can write a 978 resource page if you write that normally in your notebooks. If you don't, you can find the resource page. It's the search and rescue one. You could find the search and rescue resource page in your packet, please. You're also really going to want a ruler for this if you don't have one already. Oh, I also need to stamp your warm-ups. I have so much stamping.
Is the paper you just gave us for this class, or is that our own?
No, it's for this class. I have to teach you how to do it. I really like this problem. I think it's fun. All right. Do you guys find this? Okay. All right. First, we're going to look at the agenda for today. So we're doing two things in class, 77 and 78, which we did 77 already. 78 is the search and rescue page. And then we're going to do the thing I handed out, the histograms, box plots, and dot plots review. This is middle school math review, but I feel like, especially for the box plot, I need to teach you how to do it again, because I feel like it's been a long time. Homework is 81 to 87, and this says, did you hear about the rancher who had 97 cows in his field? When he rounded them up, he had 100. Do you get why that's funny? Yeah. Because you're like, just round up. do you get it? Because he's rounding up his cows. Because he's a rancher. Okay. I liked it. I liked it. I also like cows. I think they're cute. All right. Here we go. We need this. Next. All right. Search and rescue. I'm completely lost. Water everywhere I can see. Both burners have failed. Wait, I see land. I'm going to try to land. I think it's... Those were the last words heard from Harold in his hot air balloon. The last time the balloon showed up on radar, it was near the Solomon Islands in the Pacific Ocean. Okay, your team must determine where to send the search and rescue teams. Use the following reports along with the map on your resource page and look carefully for information that will help you draw constraints. Okay, this is a new vocab word for us. Constraints for us are really just boundary lines. So think of constraints being boundary lines like property lines or walls or something, where the balloon might be found. Give the search constraints to the search and rescue team as a system of inequalities. Be sure to identify the probable landing site on the map. Click in the lower right corner of the graph to view it. It's full screen mode. No, thank you. Okay. All right, here we go. The balloon departed from the airport at the very northern tip of the Philippines. Can you guys find the airport at the very northern tip of the Philippines? Do you see the airport at the very northern tip of the Philippines? Okay. It's a circle. It's like a open circle looking thing. The flight was supposed to follow a straight path directly to an airport in French Polynesia. The balloon's last known location was at -1,000, 1,000 near the Solomon Islands. Okay, So what we're gonna do is we're gonna make a dot at negative 1,000, 1,000. Okay, so negative 1,000, 1,000 is right here. You need to know that if you look down here, each block is 1,000 kilometers. So airports are dots and each block is 1,000 kilometers. Okay, now I need you to tell me what's the slope of that ish. I guess we don't really know the slope. It's not perfect. So we're gonna take our ruler and we're gonna go through the airport at the Philippines. Anybody been to the Philippines, and is that where the airport actually is? I have a student in fourth period who just moved here from the Philippines. I should ask her. Did everybody follow what I? I can ask Natalia tomorrow. Okay, anyway, so I went to negative 1,000, 1,000 near the Solomon Islands, and then I made a line through that and the airport at the Philippines. Okay, everybody with me so far? You have your first line in? Okay. Pilots report from a nearby airplane. We were on our way from Australia when we saw a hot air balloon sinking rapidly. I am certain that it crashed south of our flight path. This is important, but hold on. When we left Australia, we traveled 2,000 kilometers north for every 3,000 kilometers east that we flew. Okay, can you guys find the airport in Australia? Okay, and then count up to over 3 repeatedly. Okay, now pause there. It said north of. North of means not exactly on the flight path, but specifically north of that, which means we should make this line dashed. Sorry if you started drawing it already. Oh, there's Kiribati. Who knew? You guys remember Kiribati? Yeah. Okay, and then it said north, which is going to be above the line because north is up. If you notice from the little compass I gave you over here, it goes north, south, west, and east. Remember? You're gonna be like 25 years old, like doing something, and you're gonna be like north, south, east, and west, or west and east. They can be. No. That's an awful lot of shading, though, I will say. But you can't be mad if you like coloring. Okay, while we're coloring, I have a hot air balloon story for you. So I don't know if you guys have spent any time in Napa, but uh Napa pretty much every morning this time of year, all the way through the fall, will have hot air balloons in the sky, which was wonderful when I was recovering from my broken leg. my husband wasn't my husband yet, but at the time he would open up the slider so I could like look out and watch the hot air balloons in the morning, which is great. I do. Okay. However, I have a dog. I think I've talked to you about him before. His name is Buster Posey, and he's a golden retriever. And he he's deathly afraid of hot air balloons. He thinks they're going to kill him. Now, he didn't realize that Napa was a hot air balloon sort of locality until very recently. I'm not sure why, because they've been there a long time. But there was this one day where we were outside, and I swear to you, the hot air balloon was like 3 feet up in our back. It was huge and in the backyard, and it was like, like the noise they make. Okay, and the dog like freaked out and like panicked, and he was all upset. And anyway, and he's adorable and we love him, so we were trying to console him. Well, my dog also, Buster, same dog, we put in a dog door October of last year, and he couldn't figure it out. Okay, now don't be judging Buster now. He's not dumb, he's just 11. So he's not stupid. He's just old and patient. He'll just stand there outside forever, silently, waiting for someone to let him in because he's the most polite dog ever. And he just would not have like the cojones. I don't know what other word to say. He wouldn't have the bravery to like stick his nose through the door. Well, the day that the giant hot air balloon was like almost right in our backyard was the first day that he voluntarily went through the dog door. And now he goes in and out of the dog door all the time. But it was because he had to be scared out of his mind to be brave enough to go through the door. Okay, but there's an added problem. He will not go to the bathroom in the morning. He will hold it all day until he thinks that the hot air balloons are gone. Even if there's not any hot air balloons out there, he will just assume there are every morning and won't go out there any shakes. I think it's the sound because he's also really, really afraid of our Christmas inflatables. Super deathly afraid of the Christmas inflatables. I know. No. Anyway, okay, let's finish this up before I go off on a 75 other tangents and ruin your day. Okay, anyway, so looking at the dashed line, would this be a greater than or less than problem, or greater than or equal to or less than or equal to? Greater than. It's greater than because it's shaded above, which is greater. Okay, and what is the slope? Beautiful, X. And then what is the y-intercept? Gorgeous. Okay, we have one more and then we're done with this. And we get to find out and rescue the people. The Buster would not come with us on that rescue mission, probably. But, you know, he's the best. Okay, last one. I was a passenger on a flight that flew directly from French Polynesia to Indonesia. I was looking out my window when I saw the balloon going down to the north of where we were flying. Okay, can you guys find the airport at French Polynesia and find the airport in Indonesia and connect those two with a line? It says to the north, so dashed. Great job, Violet. Good question. Okay. Did I? Did I? I feel like it's wrong. And now it's all in my color, but because we shade up and then it's all of this stuff. Aren't we supposed to find where it's in the?
I feel like regardless of if we made a mistake with the shading, I think they win somewhere.
You think so? Please hold.
Or they landed in the.
Okay, well, we're just gonna finish the problem the way we did it. It's fine. It's not, we're still did all the learning here. Okay, anyway, we're shading north. Yeah. That's why I think it's wrong. It said north, right? Okay. Just checking. Okay. All right, so this one would be north again. So that's above. The slope. I believe it looks to me to be down 1/4. Hold on. Oh, it's down 1/5. Oh yeah, I guess that makes more sense. 1, 2, 3, 4, 5. -1/5 x plus 0. Mine doesn't go perfectly through 0, but that's okay. So it looks like it's got to be like right in here, right? Fiji is what we're thinking, or Samoa? What do you think? Fiji or Samoa? Fiji? Okay. I'm just gonna circle. What? Okay. All right, now can you guys, your regular packet's done, so you can put your regular packet away. Okay, and this is what we're doing next. Okay. You guys know how to make a box plot at all? Do you remember, have any idea? Okay, so every box plot starts with putting the numbers in order. That's what I need you guys to do. So first thing you're gonna do, you're gonna take 3 or 4 minutes. You're gonna take all of these movie links months, not the years. We don't care about the years. We care about these 20 numbers here. And you're gonna put them in order from least to greatest. I'm gonna put them in order from least to greatest up here on the top. So it looks like 100 is the least. Is anyone seeing anything less than 100? Okay. I feel as though I might want to do this in pencil. I'm gonna. Okay, so you guys are putting the 20 numbers in least to greatest. You guys can talk about it for sure. Help each other. Crap. I have that too. Since you and I seem to be the only ones. Sheesh, Lord of the Rings, you're low. Someone could check my work. Okay, so once you get them put in order from least to greatest, first thing you're going to do is identify the minimum number. Minimum number is the lowest one. And we're going to come down and put that in here. This box down here that says minimum. So there. The next number we're going to find is the maximum. Maximum is 201. So I'm going to write 201 in the maximum box. Okay, and then next we're going to find the median. The median, I like to use Mrs. Talbot's patented cover-up method. And I go like this. Huh, huh, huh. The sound effects are necessary, by the way. Huh, Heh, 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 heh. I did it wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and then I notice when I count in that I have two numbers in the middle. So if there was just one number in the middle, that would be the median itself. But the median is located between these two. So how do we find the number between those two? Beautiful, gorgeous. What is that? $127? Oh, duh. Of course it's 127. 127 is 4 this way and 4 that way. Okay, so come down to the median box and put 127. Okay, this is what I have so far. And there's my work. Okay. Quartiles. So this symbol right here is quartile 1. And this symbol here is quartile 3. Okay, what you do is you ignore the median. This is the most important thing about the quartiles. You ignore the median. Ignore the median. If the median is in the list of numbers, you still ignore it. Ignoring the median, completely ignoring the median. Okay, now we count in. Hey, 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 hey. Okay, quartile 1. If there was just a number there, it would be whatever that was. But this one is going to be 119.5. Can you guys all tell that it's going to be 119.5? Okay, so come down to quartile 1, 119.5. Decimals are fine, don't worry about that. Okay. He, he, he. 153. You can just sort of eyeball that because does that make sense? Okay. Right. Now it says that we need to write a title here. So okay, this is how you make a box plot. This is very important, by the way. It's called the 5-number summary. And later on in chapter 10, I'm going to ask you for the 5-number summary for things, and I'm going to want these 5 things. By the way, I don't know if you know this, but I am the statistics teacher. So, I should be good at this. Maybe, we'll see. Okay, anyway, how should we scale this dealio down here? Okay, it looks like we should do 5s. You're gonna have to throw a 200 line on there. Okay, all right, this is how a box plot goes. You draw a vertical line at each one of these five things. So 100, 119.5, 127, 153, and 201. So draw vertical lines at all five of these spots. And then you connect the middle three, that's the box. And then you make lines that go out for the whiskers. Okay, now we need to make 3 observations about the data. Okay, I tend to make these more complicated than I need to because I teach the stats class. Do you guys notice anything about the data? Here, let's say this all. That's an observation that would be accepted by the College Board from AP Stats, believe it or not. Hmm. Okay, what you need to know is the most common part is the box. So this is where kind of the averages are in here. It's not the average, but the averages are in here. Okay, I'm gonna throw one on there. These are words you might never have heard before. Box plot, you would know, that's the thing we just made. The tail of it is the longer side. So it's saying this side is longer than that side. The right side is longer than the left side. That's fancy business from stats. Okay, flip the page. Okay, we have dot plot. This is the easiest one of the 3. Does anybody remember how to make a dot plot? I think we did this. You guys didn't do it. We did it on in the cast practice thing. Okay, it says we're gonna use a title. So this is gonna be hockey team member ages. I got that from here. What is the lowest age on this? 20? Okay. age is 20, so I just started numbering from 20. Okay, how many of the players are 20? 2. So we're gonna put 2 dots. Okay, you guys can just keep going on your own. One player is 21. One player is 22. 1, 2, 3 or 23. Try to evenly space the dots. Does anybody want to offer an observation? Okay, perfect. We're going to say that in stats language, we're going to say the mode perfect observation. I just want to use the, stats vocab. You guys know mode means most, maybe. Did anyone else get 4 for 25? Okay. I crossed mine off in very thick pen and I shouldn't have done that. Okay. What are all the values? Oh, yes. Okay. That's exactly what I was going to say. All ages are between 20 and 33. Okay, and then here's another one. I said there is a possible high outlier at age 32. Do you know those words? Yeah. Outlier means like far away from all of the rest of the data. And I said high because it was a high number. Because there's an actual formula to determine if something is an outlier or not that I'm probably not going to teach you in Math 1. And we don't really know for sure because we're not willing to do that formula. Trust me, you don't want to do it. So we just say possible for now. If you take AP Stats, I'll teach it to you in your summer homework. But for now, a whole chapter. I made videos if it's any consolation. Okay, last one. Whoa, sorry, I'm too fast. Okay, last one is a histogram. And histograms have bins. So bins meaning intervals that you make things in. Yeah. Okay, so A histogram looks like a bar graph, but it's not. It's a like continuous bar graph. And the lowest stock price I see up here is 123. So what we're gonna do is we're gonna count how many of them, how many of the prices are between $123 and $123.99. This one's gonna be 124. Okay, next thing I'm gonna go through all of the numbers up here and I'm gonna put them in their right spots. So you guys see what I'm doing? I'm just figuring out what interval the particular number goes in. This is 128 number, so that's gonna go in this one. See what I mean? This is 127 number, so it's gonna go in this one. Did I get them all? Yeah, I did. Okay, then what you do is you count how many numbers are in there. So that has 3, that has 4, that has 3, that has 4, that has 5, that has 1. You guys with me? Okay, then set your graph up like this. So I started at the lowest. And then I put frequency here. Okay, and then the first one is 3 tall, then 4, then 3, then 4, then 5, then what? I'm coloring a lot today.